Okay, in the last video we learned about moles. In this video we're going to learn about something called molar mass. It's almost the exact same concept, honestly. So the idea is we were able to convert from grams to moles for individual atoms, and from moles to grams and to number of atoms and stuff like that. For individual atoms, for individual elements. Now we can also do it for compounds. So for example, if we had something like NCl3, nitrogen trichloride, the way this works is the overall mass of this is equal to 1 nitrogen plus 3 chlorines. So we can look each of those values up. Nitrogen is 14.00, I'm just going to round it to 3 decimals, 14.007, and this is 35.453. So 14.007 grams per mole plus 3 times 35.453 grams per mole. You add it all up. So 14.077, 007 plus 3 times 35.453. And I got a number of 120.366. And this tells us that 1 mole of this molecule weighs 120.366 grams. Okay, molar mass is the most generic version of this term. The other words for it are molecular weight and formula weight. Molecular weight is pretty much any organic compound, and formula weight is any sort of salt, but they all technically mean the same thing. I am probably going to say molar mass more often than anything else because it's the generic version that encompasses both of those. But occasionally, especially in like labs, occasionally you'll see things referred to as molecular weight or formula weight. It means the same thing. I'm going to use molar mass because it's more universal. So now that we've calculated this number, we honestly can do exactly the same things that we were doing in the last video. So let's try this number in an example. So we want to know how many moles are in, 37.55 grams of NCl3. Okay. If we hadn't done this part first, the first thing you would do is add up the molar mass of NCl3. Okay. But since we've already done that, we can just use this number. So 37.55 grams, and we know that there's 120.366 grams per mole of this stuff. The grams will cancel out, and we'll be left with moles. This has 4 sig figs, this has more than 4, so we're okay. 37.55 divided by 120.366. And the answer I got is 0.311965, whatever. 4 sig figs would be 0.3119. That would round up to 0.3120. And then the answer would be in moles. Okay, but you'll notice this part behaves exactly like we saw in the last video. The only new bit is having to add up each of these individual components. Okay, so let's try a couple more examples just to make sure we've got them in our notes. Okay, we want to know how much does 0.2864 moles of sodium sulfate weigh? Okay, so we know our compound, we know how many moles we've got, and we're trying to convert from moles to grams. So the very first thing we're going to have to do is add all these things up. Okay, so we're going to have to add up 2 sodiums, 1 sulfur, and 4 oxygens. So we have to look each of those up. And honestly, I just kind of add it as I go. So 2 sodiums, sodium is 22.990 times 2 plus a sulfur, which is 32.066, plus 4 times oxygen, which is 15.999. And I got 142.042. That is the molar mass for this compound. So what we do is we take the number we started with, and this is our conversion factor between moles and grams. So 0.2864 moles of sodium sulfate. Then we use the molar mass, which is 142.042 grams per mole. Grams is going to go on top, moles is going to go on bottom because we want the moles to cancel out. And whatever this number is, we take it, we multiply this together, and we should be good. This has 4 sig figs, so we need our answer to have 4, which would be 40.68. So, technically not drastically different than what we were doing in the last video. The only extra step is that you have to add up all the components, like we did up here, to get the overall molar mass. But it behaves exactly the same way that the molar mass did. Like if you only had one atom at a time, it behaved, the calculations are set up exactly the same way. All right, thank you.